What if I told you that aluminium was once worth more than gold? Sounds unbelievable, right? But it's true. At one point in history, Emperor Napoleon III reserved aluminum plates and cutlery for his most honored guests, while everyone else was served on gold. Today, however, the world produces nearly 200,000 tons of aluminum every single day. In the United States alone, more than 4.6 billion kilograms of aluminum are used every year. Modern civilization simply couldn't function without it. From massive airplanes soaring through the sky, to the cars on our roads, and the high voltage power lines delivering electricity to our homes, aluminum is everywhere. So, how does an ordinary red rock become one of the most important metals on Earth? Let's find out. More than 8% of Earth's crust is made up of aluminium, making it the most abundant metal on the planet. Unlike gold or silver, however, aluminium is never found in its pure form. Instead, it exists inside a reddish colored ore called bauxite. The world's largest bauxite reserves are found in Australia, Guinea, Brazil, and Jamaica. Australia's Huntly mine, operated by Alcoa, is the largest bauxite mine on Earth, producing around 23 million tons of bauxite every year. Mining this rock is anything but easy. Workers drill deep into the ground and use powerful explosives made from ammonium nitrate and fuel oil to blast apart the earth. These explosions are so powerful that a single blast could demolish a 10-story building. Depending on the site, each blast can expose anywhere from 5,000 to 100,000 tons of bauxite. Producing just 1 ton of pure aluminum requires about 4 tons of bauxite, which is why mining companies invest millions of dollars in massive equipment. Some of the giant excavators used in these mines cost around $20 million, while enormous off-road haul trucks can carry 270 tons of bauxite in a single trip. Even more impressive, a giant excavator can completely fill one of these trucks in about a minute. Once the ore reaches the refinery, it enters a process known as the Bayer process. The bauxite is first crushed inside huge rotating drums filled with heavy steel balls until it becomes a fine powder. This powder is then mixed with a hot caustic solution that dissolves the aluminum compounds while leaving impurities behind. The purified solution is then cooled and processed until tiny white crystals form. This material is called alumina, or aluminum oxide, and it is the key ingredient needed to produce aluminum metal. Next, the alumina is shipped to aluminum smelters around the world. A single cargo ship carrying alumina can produce roughly 35,000 tons of aluminum. At the port, enormous vacuum systems unload the powder at rates of about 300 tons per hour, moving it into large storage silos before it enters the production process. Although alumina melts at about 2050 degrees Celsius, 3722 degrees Fahrenheit, manufacturers mix it with molten cryolite, reducing the melting temperature to around 950 degrees Celsius, 1742 degrees Fahrenheit. This dramatically lowers the energy needed for production. The molten mixture is then placed into large electrolytic cells, where an enormous electric current flows through it. In fact, electricity accounts for roughly 1/3 of the total cost of producing aluminum. A single large aluminum smelter can consume enough electricity to power hundreds of thousands of homes. During electrolysis, oxygen separates from the alumina and combines with carbon to form carbon dioxide, while pure molten aluminium sinks to the bottom of the cell because it is much heavier. Every 36 hours, the molten aluminum, still glowing at nearly 950 degrees Celsius, is siphoned out into specially insulated containers that keep it from solidifying during transport. It is then transferred to refining furnaces, where it is reheated and filtered to remove hydrogen and other impurities. Finally, the purified molten aluminium is poured into molds to create large blocks known as ingots. These ingots are cooled under carefully controlled conditions to prevent cracks or internal defects. Once solidified, they are shipped to factories around the world, where they are transformed into aircraft, automobiles, construction materials, beverage cans, electronics, and countless other products we use every day. The story behind aluminum's discovery is just as fascinating. In 1807, British chemist Humphrey Davy first suggested the existence of the metal while studying a mineral called alum, but he couldn't isolate it. About 20 years later, Danish chemist Hans Christian Ørsted successfully produced small amounts of aluminum. Unfortunately, the process was extremely difficult and incredibly expensive, making aluminium even more valuable than gold for many years. Everything changed in 1886 when Paul Héroult in France and Charles Martin Hall in the United States independently discovered an efficient method of extracting aluminium using electricity. Their revolutionary process, known today as the Hall-Héroult process, is still the foundation of modern aluminium production. Thanks to their breakthrough, aluminium transformed from one of the world's most expensive metals into one of the most affordable and widely used materials on Earth. It's truly incredible to think that an ordinary red rock can be transformed into the metal that powers modern civilization. If you enjoyed this video, don't forget to leave a comment, hit the like button, share it with your friends, and subscribe for more amazing stories about science, technology, and engineering.